that you don't have to do any extra studying tonight. Doing the homework is studying. It is due by 8:20 tomorrow morning, and in Canvas. All right, with that being said, I need you to get up out your seats. I'm going to teach you a new dance. All right, so with that being said, the movie Continental Drift, or Ice Age, had Ice Age had portions of it, and Ice Age relies a lot on realistic information about Pangea and the Continental Drift, and also geologic time. If you remember, when we talked about geologic time, Ice Age represents when there was no what happening?
Natural.
Geologic time. Remember, geologic time are layers of rock being laid down. If it was Ice Age, meaning everything was frozen, so at that time, nothing was happening. There was no rock layer, so that would be the non-deposition, if you remember from last year. But Ice Age talks a lot about that, so that's why I showed you that song, just to kind of get you out your seat, but have you think about Ice Age, because we're going to look at a little bit more from that. Now, at your locations, there are 1 or 2 or maybe 3 baggy pieces of puzzles. I want you to go ahead and take your puzzle pieces out. They are linked together, so do not take them apart. Just take your whole entire stash apart. If there are 3, make sure each person gets their own. If there are 2, make sure groups get their own. So you guys need to share. I'll give him one and you take one. And then give the other 2 another one. So again, there are bags of puzzle pieces. The puzzle pieces are already together to cite a certain piece. If there are enough for everyone to get their own, you give everyone their own. If they're not, then just make sure at least it's 2 people sharing one piece. It only is 2 people sharing one piece, but you're not working as a group. Now I want you to just look at your piece for a moment and just examine your piece that you have, whether you're working with a partner or by yourself. Now, what I want you to do in just a second, you're going to get up and you're all going to come into the center, and you're going to try to put this puzzle back together. But if you notice right now, you are in different areas of the classroom, correct?
Yes.
Right now, as you look at your piece, it looks like your piece just stands alone, right?
Yes.
It's all by itself, surrounded by nothingness, correct?
Yes.
In a moment, we'll see if that really is true. So go ahead and get up and see if you can link the puzzle pieces. Some people will have to come to you there.
You know what we're talking about.
Y'all connected, right? I got it. I did it on myself.
Is everything together?
Yes.
Did your puzzle come out and look like this? The light is glaring. Hold on.
Yeah.
Did it come out looking like this? Okay. Now, I want you to look at the backs and get your pieces back and take them back to your area. What were some of the things that you looked for in linking these pieces together? Michaela?
Color?
She looked for color. Put it in a Ziploc bag, please, and thank you. She looked for similar colors, okay?
Like strawberries at the bottom.
Similar things that may have matched. So if you had a piece of a strawberry, you try to link it and see if there was the other piece of the strawberry. Okay, the ridges on the edges to see if they match with the other edges. Same thing with you. The outer part, okay. Okay, lines of symmetry. He looked for similarity and symmetry. So if you can imagine a landmass being the continents that we live on, if you can imagine these pieces being like the puzzle pieces, where things are matched together, this is the whole concept of Pangea and continental drift, where the pieces fit together like a puzzle, And at some point, the theories say that they have drifted away. But when we look at the different continents, we see that there are some lines of symmetry. We see that there are some matching shapes for it. We also see matching strawberries. And when I say strawberries, what I mean is in one part of the world, let's say over here, where Miracle's sitting, let's say this is dry land. And let's say this is land that is normally wetland. When we learned about and we talked about our different areas that are wet and dry, and we looked at weather. So normally this area is dry, normally this area is wet. But we notice that there are fossils of fish in the dry land, and there's also the same fossils of the fish in the wetland. What does that tell us?
That the ocean was closer.
At possibility, those lands were closer together if those fossils are there, especially when it's in one part of the world and the other part of the world. What about if we looked at a piece of land that was that is now closer to the equator? What would we say about that land if it's closer to the equator? It's hot. But if we go there and we see that there are evidence of glaciers that used to be there, we could assume that at one point it may not have been closer to the equator. It may have been somewhere else. And that is the whole theory of Pangea and continental drift. So what we're going to do right now, and you'll probably have time to start your homework, but we're going to go ahead and take some notes. They're very short notes. Can you all see this paper? Okay. Make sure that you put your page number on here, and I believe for this class it's page 47, but whatever class page number it is, then you want to make sure you put that. The title of this is going to be called Pangea. And continental drift. Please make sure that you write it as I do, and I probably should zoom that in. So if I write it in a particular spot on the paper, make sure that you do the same. Can everyone see that? Let me focus that in. Is that good? Right there. Oh, just put yours in mine and just grab one of mine.
You gonna do this whole thing?
No. Well, yeah, just the front part. The theory. What's a theory?
The thought.
It is not just a thought, but it is a thought, but it has much more substance to it.
It's like an idea. It's kind of like a theory. It's not like a theory, but it's like how the things move, the continents move. It's like they have a theory to.
You guys have the right words. It's an idea, it's a thought, but what makes it different from I think I want to eat chicken tonight?
It has
It does have evidence, good, to back it up. So therefore, there has been multiple things that has showed that this could possibly be true. The fact that we have fossils in different parts of the world, the fact that they kind of fit like a puzzle, the fact that temperature changes are different, that this is a theory, it's a thought that is backed up by evidence. So the theory of continental drift, this is why we call it a theory. Is this large enough for you all? Or do I need to zoom it some more?
Some more.
right there. Glasses.
Okay, is that good? All right. All right, so it's a hypothesis. What's a hypothesis? Educated guess, good. That all continents, hypothesis that all continents what? Used to be joined together, yep. in a single, and I'll give you guys a moment to get caught up writing that. Used to. Yeah, it's used to. That means because it's past tense. Okay, used to be joined together in a single mass. Oh, I did single again. In a single landmass. And a single landmass called what? Pangea. Now notice when we did the dance earlier, he said step up, step back, then he said step to the right, then nope, we didn't crisscross before we slid. Why did we slide? Because the continents slide. Now they're not I don't want you guys to get the thought of thinking that right now we're sitting here and we're just floating along and we go outside from school like, oh, I need a boat. No, we're not sliding like that. It does take millions of years to do this, but theory has said it is happening. So, but before we go on with the but, what is Pangea? It's a whole landmass. So when we go ahead.
You know how everything used to be together. So basically, that's what you're talking about.
So based on your pieces that you have at your desk, what would have been Pangea? Is what you have right now Pangea? No. What you have right now is what? What it looks like right now. What would have been Pangea? When you got them all together. Okay. Since then, what happened with Pangea? What happened to the continents? They drifted apart. Now remember, theories are backed up with miracle evidence. Very good. So we're going to put, there are 3 pieces of evidence. Because it is a theory, it is backed up with evidence. So we're going to go ahead and jot down these 3 pieces of evidence. Before I do that, can you guys see this red right here? Up here in the corner? Because I want to write with this and I want to make sure that you can see it. Let me actually get a color piece so maybe you'll be able to see that better. Yes.
One of the things where, like, if you look on the map, you can see that some continents connected.
Yeah, exactly. Just like puzzles, when you look at we're gonna look at that a little bit later. But when you look at a map, you can see that the edges of North America kind of fit with the edges of another continent, and you'll see that it doesn't look like it fits perfectly, maybe because erosion or non-deposition and stuff like that. But it does look like it kind of fit together like a puzzle.
So South America and Africa would be together. If we wouldn't have broken through.
Probably, yeah. I'm science all the way. But here we go. So 3 pieces of evidence. One of the evidence, which you all just talked about, and you guys can see this red, right? Okay. One of the pieces of evidence would be the fact that we have these things called what?
Crosses.
Thank you. We have these things that look like puzzles. These puzzle pieces. I tried my hardest. What? Those look just like puzzle pieces. Whatever. So these would be shapes of the continents fit together. So this is one theory. Now, we kind of harped on this theory a lot, the fact that they fit like puzzles. What's another theory that I talked about? Think about what Miracle said about the strawberry.
What?
Okay, let me get your minds right. The strawberry was something that was on the puzzle piece. We're looking at something that's in fossils. So another piece of evidence. You guys can see that purple? Okay. And this is my example of a fossil. It's kind of like a shell, like a fossil shell. I don't know. All right, well, let's do something like this. That's a footprint. Thank you. So these would be fossils. So what about fossils, though?
It's still like what it
That is what fossils are, but what about fossils with this theory?
Oh, it's like
it's the same type of fossils.
Exactly. So same or similar fossils on edges of continents. Same or similar fossils on edges of continents. Yes. Uh-huh.
So the continents are basically fossils.
No. There's fossils in the continents, in the rocks. So continents.
If you think about it, she said pieces.
Well, let's finish getting this written, and then we'll talk about it a little bit more. Continents that look like they fit together. And I'll fix that. So what this means is one continent that looks like it fits like a puzzle, which is the first piece of the theory, to another continent. They look like they fit together. So we could say, okay, possibly these used to be together because they look like they fit. Is that enough? Maybe they're like, okay, that could be enough, but let's go more to make this more of an understandable theory. Not only do these continents look like they fit, on the edge of the two continents, there are similar fossils. So it says that, because remember, fossils are history of living things, past things that lived. So it says that in the past, when these things lived, they lived together. Now they're not. Understand? Okay. So what would be a third theory? We talked about the puzzles fitting together, fossils, and then I mentioned something else when I talked about the equator. You said something about glaciers, but be a little bit more specific.
How to get to
Go deeper with that glacier concept that I was talking
It
about.
used to be somewhere where it was cold.
Climate, good. You guys can see that blue?
That's that Carolina blue.
Thank you.
So for climate, I'm going to draw what I think looks like maybe a thermometer. I know, like exclamation point, be quiet. I'm going to put these graduates next to it. So a thermometer. Oh, that I could put. I could put a cloud. Thank you. But I put a thermometer because temperature, because that's what we're really looking at. So warm climate. This is an example. Warm climate plant fossils.
Oh, that's okay.
Well, you could put it under here. This is explaining that theory of climate. So warm climate plant fossils are found in the Arctic. This is, part of the theory because they did find warm climate plant fossils in the Arctic. Arctic is characterized of being what type of temperature? Cold. So how in the heck did these warm plant fossils get there? At some point, it might have been in an area where it was warmer. Arctic may not have been in a cold part of the world. Any questions about these notes? Okay, then you should be able to take these notes and interpret them or understand them to the point where you'll be able to answer your questions for your homework. So in Canvas, you are going to log in. You're going to look for the assignment titled Pangea and Continental Drift questions. I think they're called either analysis questions or questions. And you're going to work at answering those while by interpreting your notes.